Okay, on to part two of the video. So what we're going to do is we've done all of this work making the unit circle, which, to be honest, this is not my favorite approach for evaluating trig functions, but because the amount of work that goes into it is a lot to only evaluate a couple of trig functions. But if we've done the work to come up with a unit circle, it makes evaluating trig functions super, super easy. So we're going to use this unit circle to evaluate trig functions at certain angle measures. Okay, so directions ask us to evaluate the following functions. Number one asks us to find the cosine of 7 pi over 6. So if we want to find the cosine of 7 pi over 6, we go over to 7 pi over 6, which is an angle in quadrant 3, and we define cosine as the x-coordinate of the point on the unit circle. So we go over to 7 pi over 6. The x-coordinate of that point is going to be, negative rad 3 over 2. Okay, if we want to evaluate the secant of 11 pi over 6. So secant of 11 pi over 6, we go over to quadrant 4, and we define secant as 1 over x. So secant is the reciprocal of the x-coordinate. So the reciprocal of the x-coordinate at 11 pi over 6 is going to be 2 over rad 3, which when we rationalize that, multiplying the top and bottom by rad 3, that becomes 2 rad 3 over 3. Okay, the tangent of 4 pi over 3. So if we want to figure out the tangent of 4 pi over 3, we go over to 4 pi over 3, which is an angle in quadrant 3. And tangent is going to be y over x. So the y-coordinate at that point is negative rad 3 over 2, divided by the x-coordinate, which is negative 1/2. The fact that both the numerator and denominator are negative, we can make each of those factors positive. And then if I want to simplify this expression, I can multiply the numerator and denominator by 2, which makes that become rad 3 over 1, which is rad 3. All right, for problems 4 and 5, we have to do a little bit more work with those. For 4, if we want to find the cosecant of 19 pi over 6, if you look at your unit circle, 19 pi over 6 is not an angle on that unit circle. And the reason that it's not is that angle 19 pi over 6 is not between 0 and 2 pi. So we have to take what we talked about in the previous lesson, dealing with coterminal angles, and we have to find an angle that is coterminal with 19 pi over 6 that is between 0 and 2 pi. So if I subtract 2 pi, which is like subtracting 12 pi over 6, 19 pi over 6 minus 12 pi over 6 makes that angle become 7 pi over 6. And that angle now is between 0 and 2 pi. So we go over to 7 pi over 6, which again is an angle in quadrant 3. Cosecant is 1 over y, so it's the reciprocal of the y-coordinate, and the reciprocal of negative 1/2 is going to be negative 2. Same thing with 5, the cotangent of 11 pi over 4, that is not between 0 and 2 pi. So we have to find an angle that is coterminal with that angle that is between 0 and 2 pi. So if we subtract 2 pi, that's like subtracting 8 pi over 4, and 11 pi over 4 minus 8 pi over 4 gives us the cotangent of 3 pi over 4. So we go over to 3 pi over 4, which is the angle in quadrant 2. Cotangent is x divided by y. So if we take the x-coordinate and divide it by the y-coordinate, that's going to be negative rad 2 over 2 divided by rad 2 over 2, which winds up becoming negative 1. Okay, last topic for us to go over, then we'll do some examples with this, deal with even and odd trig functions. So there are 4 odd trig functions. The 4 odd trig functions are sine and its reciprocal cosecant, and tangent and its reciprocal cotangent. And the two even functions are cosine and its reciprocal secant. Now, if you guys remember back to us looking at even and odd functions, the way that we algebraically show that a function is odd is by taking the opposite of the input value. So if we take f of negative x, that's going to give us the opposite of the original function that we started with. And if we have a function that is even, the way that we can algebraically show that a function is even is when we take the opposite of the input value, f of negative x, it gives us back the original function that we started with, f of x. So let's take a look at how we can use this to evaluate trig functions, where the angle that we're looking at is a negative angle. So for the first example, the directions ask us to evaluate the function where we have the cosine of negative 5 pi over 6. So again, when we look at that, that's of the form f of negative x. And because cosine is an even function, f of negative x is going to be equal to f of x. So if I want to find the cosine of negative 5 pi over 6, that's going to be equal to the cosine of 5 pi over 6. So all we have to do is go to our unit circle. We go to the angle 5 pi over 6, which is that angle in quadrant 2. Cosine is going to be the x coordinate of that point, which is going to be negative rad 3 over 2. I'm not going to work this through, but if the problem asked us to find the sine of negative 5 pi over 6, because sine is an odd function, f of negative x is equal to negative f of x. So I can rewrite the sine of negative 5 pi over 6, because sine is odd, as negative the sine of 5 pi over 6. And then I would go to that same angle. Sine is the y coordinate, so we would just wind up taking the opposite of that y coordinate. Now, to be honest, I don't use the even and odd properties unless I'm forced to in a problem. I'm going to show you another technique or another way to evaluate the cosine of negative 5 pi over 6, which I personally like a little bit better. Okay, so what I'm going to do instead is, because the angle that we're given, negative 5 pi over 6, is not between 0 and 2 pi, I'm going to find an angle between 0 and 2 pi that is coterminal with that angle. Okay, so to find an angle that is coterminal with negative 5 pi over 6, I'm going to add 2 pi, which is like adding 12 pi over 6. So negative 5 pi over 6 plus 12 pi over 6 is going to be 7 pi over 6. Okay, so all I have to do now, because my angle is between 0 and positive 2 pi, is I go over to the unit circle. 7 pi over 6 is that angle in quadrant 3. Cosine is going to be the x coordinate of that point. So that is going to be negative rad 3 over 2. And we get the exact same result, either using the even and odd properties or finding the angle that is coterminal with the given angle. Just going forward, just so you guys know, I'm going to use the second approach with these last two examples. So I'm going to find an angle that is coterminal with a given angle that is between 0 and 2 pi. So when we look at number 2, the tangent of negative 13 pi over 4, again, that angle is not between 0 and positive 2 pi to start with. So I'm going to find an angle that is coterminal with that angle that will be between 0 and 2 pi. So I know I have to add 2 pi one time. So if I take negative 13 pi over 4 and add 2 pi, that is adding 8 pi over 4. This becomes the tangent of negative 5 pi over 4, which is still not between 0 and positive 2 pi. So I have to add 2 pi again to find an angle that is coterminal that is. So when I take negative 5 pi over 4 and add 2 pi to it, that's like adding 8 pi over 4. This becomes the tangent of 3 pi over 4. And the tangent of 3 pi over 4 is going to wind up being -1. You guys can work through that on your own. Okay, for 3, the secant of -23 pi over 3. Okay, we're going to have to add 2 pi several times here to find an angle that is coterminal that is between 0 and 2 pi. So if I add 2 pi, which is like adding 6 pi over 3, -23 pi over 3 plus 6 pi over 3 is -17 pi over 3. When I do it again, adding 6 pi over 3, we get -11 pi over 3. When I add 6 pi over 3 again, we get -5 pi over 3. And then when we add it again, we get the secant of pi over 3. So our angle is now between 0 and 2 pi. So we go over 2 pi over 3. That is the angle in quadrant 1. Secant is going to be the reciprocal of the x-coordinate. So the reciprocal of the x-coordinate 1/2 is going to be 2. Okay, so this is 2, which makes that equal 2 as well. Okay, that's it for today's lesson. If you guys have any questions, please look to the directions that I posted on Schoology. Hope you guys are well. Take care.